Homeostasis is the most important principle in physiology. The word homeostasis is broken down into homeo and stasis. Homeo means same, stasis means state. The body maintains homeostasis or steady state at all times, even though the outside variables might change. The body has a set point for various variables such as temperature, pH or acid base, salt, water, and blood pressure, to name a few. When the set point is reached, the body is in homeostasis. If the body deviates from the set point, there are many mechanisms that bring it back to the set point. Let's take a look at how homeostasis works. When the body temperature goes above the set point, it is picked up by thermoreceptors in the skin and elsewhere in the body, and it is sent to the thermostat in the brain, which is the hypothalamus. The hypothalamus sets the temperature at 37 degrees Celsius. When it detects a deviation above the set point, it sends messages to the cutaneous blood vessels and the sweat glands. Cutaneous blood vessels are the blood vessels in the skin. They are then stimulated to vasodilate. When vasodilation occurs in the skin, it helps to release heat through the skin. Sweating releases even more heat through the skin via evaporative cooling. This results in the body temperature going down. That's the response of the homeostasis mechanism. So we start with the body temperature going above normal. That's the stimulus. The thermoreceptors are the receptors that sense this change. The hypothalamus is the control center that sends the messages to the cutaneous blood vessels and sweat glands, which are the effector organs or effectors. The vasodilation and sweating occurs, bringing the body temperature down. The stimulus and response are in opposite directions, and therefore we call this a negative feedback. Let's see what happens when the body temperature goes below the set point. When that happens, this is sensed by thermoreceptors in the skin and elsewhere in the body, and it sends information to the thermostat, which is the hypothalamus. The hypothalamus detects the deviation below the set point and sends messages to the cutaneous blood vessels and the skeletal muscles. In other words, the heating system is turned on. The cutaneous blood vessels undergo vasoconstriction. Vasoconstriction helps to conserve heat via the skin. Skeletal muscles cause shivering to take place, and shivering releases energy into the body, and this allows to conserve even more heat. The body heat increases and the body temperature increases as well. This is the response. The stimulus we started was body temperature going down. The thermoreceptors are the receptor. Hypothalamus is the control center. The cutaneous blood vessels and the skeletal muscles are the effectors. And the vasoconstriction and shivering help to raise body temperature. Again, the response and stimulus are operating in opposite directions, and therefore we call this a negative feedback. The endocrine system plays an important role in bringing about rapid change. A good example is what happens during childbirth. During childbirth, the fetus's head presses against the cervix of the mother. This causes the receptors in the cervix to send messages to the brain. In the brain, the pituitary gland is turned on and it releases a hormone called oxytocin. Oxytocin is released into the blood, reaches the uterus, and causes strong contractions. So when the uterus contracts really strong, it squeezes against the fetus and makes the fetus head press even more against the cervix. As a result, this pathway is repeated many times in a positive feedback loop. This continues until the baby is born. And the purpose of a positive feedback loop is to bring about rapid action. Let's compare positive feedback and negative feedback loops. Positive feedback, the purpose of this is to bring about rapid change, and the purpose of negative feedback is to maintain homeostasis. In positive feedback, the stimulus and the response both move in the same direction. They move upwards, as we saw in the childbirth example. In negative feedback, the stimulus and the response, they move in opposite directions. When one goes up, the other goes down.